This is the video lesson for Algebra 1, 3.7, Absolute Value Equations and Inequalities. So here we're going to be solving inequalities and equations involving absolute values. So we're going to look at solving these just like we solve all the other equations, but this time, after we put our tracks down, we find our variable. Before we're actually looking for a variable, we're looking for our absolute value signs. So we want to get this whole, anything with the absolute value signs by themselves first. And then we'll take care of the absolute value symbols. So in order to get that by itself, here we're going to have to subtract 2 from both sides. And so this is the absolute value of x is equal to 7. And then to get rid of absolute value symbols, what you need to do is remember absolute value. If you have the negative of something, it changes the sign. So we have to take into account when this x is positive. And so that would be x equals 7. And then if this x is negative, so that would be x equals negative 7. And so to get rid of it is you write whatever's inside the absolute value symbol on the left side here when you split them in two. And then you write whatever's on the right side here. You also write it here, but whatever it is you add a negative sign to that for the right one. Okay, so try that for this equation here. Get your absolute value of n alone first, then split it into 2 and change the sign of your second equation. So here the solution would be x equals 7 or negative 7, right? Because if you plug that negative 7 in here, it becomes a positive 7. When you add 2, it becomes a 9. Okay, so try this next one on your own. Press pause and then check back for the solution. Okay, here you get either 3 or negative 3. Also, I'm not graphing and I'm not checking these solutions because graphing this is just a dot on a number line. So we're not going to bother doing that until we start doing maybe some compound inequalities or yeah. Okay, so moving on to a word problem. Starting off 100 feet away, your friend skates towards you, then passes by you. She skates at a constant speed of 20 feet per second. Her distance, d, from you in feet after t seconds is given by d equals the absolute value of 100 minus 20t. At what times is she 40 feet away from you? So you can think about her, right? Here's your friend, or here's you, right? Your friend is here, and she's skating towards you, but then she passes you, and then she comes back, right? So say this is 40 feet away, and then this is also 40 feet away. So there's going to be 2 times when she's 40 feet away from you, right? So that's all it's looking for. So to solve, we're just going to solve this equation when d is 40, right? At what times is she 40 feet away? So when the distance is 40. So we'll plug in 40 for d. 40 equals the absolute value of 100 minus 20t. And then our absolute value symbols are already alone on one side of the equation, so we can just go ahead and split this into 2. So we have 100 minus 20t. This is what's inside the absolute value symbol. So this is 100 minus 20t. They're both going to be whatever's inside, you put equal. And then whatever on the other side, for the first one, you just leave the positive version, 40. And then this next one, you make negative 40. And then you just solve both of those equations. So here we will subtract 100 from both sides. We can actually solve them all at both at the same time. This goes away. This becomes negative 20t equals negative 60. This becomes negative 20t equals negative 140. And then when we divide both sides by negative 20, t equals 3. And then t equals 7. So at 3 seconds and 7 seconds, which is C. Okay. So here is one for you to try on your own. And the absolute value symbols are already by themselves, so split them in 2, set up your 2 equations, and then solve them both. Check back for the solutions after you press pause. Okay, here we get 3 and negative 7/3. When we split this, remember whatever's inside stays the same on the left. Whatever's on the right stays as long as it's positive, and then you make it negative for the second one, and then solve. And then if you plug 3 in here, you get 9 minus 1, which is 8, which is the absolute value of 8 is 8. And then here, if you plug in negative 7/3, the 3 cancels. This becomes negative 7 minus 1 is negative 8, which the absolute value of negative 8 is also 8. So they both work. Okay, moving on to just a little bit more complicated. Here we're going to try to get, right, this is what we're highlighting. We want to get this alone first. So to do that, we have to subtract 12 first on both sides. This becomes 3 times the absolute value of 2z plus 9. And this is negative 2. And be really careful here. You cannot distribute this 3 into absolute value symbols. So you need to get rid of that first. And to do that, we'll divide by 3 on both sides. So this becomes absolute value of 2z plus 9 equals negative 2/3. Okay, and then here we have it all by itself now. We can split it into 2. This is 2z plus 9 equals, and then we write this here as long as it's positive, I said. Right, so as long as this is positive, you can write it. But since this is negative, this is a clue that this is no solution. So you cannot have an absolute value symbol equal a negative number, right? Because anything that you put in here is going to turn it positive. So this is going to be no solution. And this is the clue that you have whenever you're doing this. When you split it, if this first one you write and you write what's here is already negative, as long as it's not a variable, if it's a negative number. If it's a negative variable, that's fine because that would give you a negative value. So, but just be careful. If it's a negative number, then that means no solution. Okay, so try this next one on your own and then press, after you press pause, and then check back for the solution. Okay, so you can see here when you add 5 to both sides, this still is a negative number. So when you split this out and you do the first one, you don't get a positive number here. And you get a negative number, so there's no solution here. Okay, so when we solve absolute value inequalities, you're going to do sort of the same thing when you split your 2 up, but you're going to change the sign on the second one. And this explains why that's true here. So let's look at and actually solving this. So here we have the absolute value symbols on their own. So this is where you're going to split. We don't have to do any operations yet. You're going to take the inside, 8n, and then you're going to keep the inequality symbol the same here and then make that a 24. You're going to flip it on the second one and make it a negative 24. So the only difference really with the equal sign, then the equal sign is here, for the second one, you make this negative and you flip the sign. So it's just one extra step here, and then you solve them. So here we would just divide both sides by 8, so n is greater than or equal to 3, and here n is less than or equal to negative 3. And so to graph the solutions, so this one makes sense to graph, right? If we go from negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Maybe I'll add an extra one in here. Okay, negative, there you go. You didn't have to stay for that. Okay, so then we have a 3 closed hole, and it's greater than. And then we have a closed hole on the negative 3 and less than. So basically what this is saying is anything you pick on this side of 3 is going to work for this, and then anything you pick on this side of 3 will work for this. Okay? So this is like an OR. Okay, so try this next one on your own, and don't forget to graph your solutions after you press pause, and then check back for them. Okay, and then here, when you solve it, you get x is greater than or equal to 1/2, which is between 1 and 2, and then it's less than or equal to negative 9 over 2, which is actually 4.5, not 3.5, I just realized. So this actually is here, 9 over 2, so forget this. Fill it in here, and then there we go. Okay? So last one, word problems. A company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies in weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? Okay, so if we make x the weight, let's just call it x equals the weight, the actual weight. And if we take that weight and we subtract 213, we should be getting, the difference should be less than or equal to 5. Right, in the absolute value. So it could go negative or it can go positive. So here we can split this into 2. So x minus 213 is less than or equal to 5. And then x minus 213 is greater than or equal to negative 5. And so this becomes x is less than or equal to 213. We add 213 to both sides. So 218, and then we add 213, oops, to both sides here, and we get x is greater than or equal to 213. Why am I doing this on the calculator? 208. So it can be between 208 and 218 grams. This one was probably harder to turn into an algebra problem than it was to just say, oh, I just subtract 5 from 213 to 213 or add 5 to 213. But this is how it would work with algebra. Okay, so here's one last one for you to try on your own. Press pause and then check back for the solution. Okay, and then here you do the same thing but just with these different numbers. And then you basically add 0.05 to 32, you subtract it from 32, and you get between 31.95 and 32.05. Okay, that's it. Enjoy.